Well, hello. I'll have a go at explaining all the acronyms, certainly the ones I understand myself. So, yeah, today I'd like to talk about DNS-SD in the kind of NMOS environments. And by that, I mean, primarily, I mean ISO 4, right? So registration and discovery. So as you've probably heard all of the benefits of moving to IP, but essentially moving from SDI to IP, it gets you a ton of really good stuff: flexibility and scale and agility and connectivity and all sorts of stuff. You can rebuild everything that you've built in the past in SDI, and you can build it in a much more flexible way. And you're kind of riding on the back of technological velocity. So, you're riding on the back of Moore's law, which is running at, in terms of x86s, it's still doing the right thing. It's still doing the, once every 18 to 24 months. But on the back of network switches, it's running faster. So, what was a fast switch 3 years ago, 4 years ago, is a 10 gig switch. Now a normal fast switch is 100 gigs, and you can buy the 400. So that kind of speed is it's something we're not used to in the kind of media world. And the other thing that we're not that used to is this, but we're getting used to with this move to IP, is moving away from kind of bespoke kit, moving away from hardware-centric kit, moving away from proprietary protocols and proprietary ways of working towards COTS and software and IT and standardized things. And to me, one of the massive benefits of doing all of that is you can start to, I'm going to jump to my bottom point, right? You can start to jump on the shoulders of giants. You can start to, move your way up that ISO stack, and you can OSI stack, and you can start to expect stuff to be there. You can start to leverage the functionality that is just naturally in a network. It's just naturally in software. It's just naturally in a network stack on a Windows machine or a Linux machine or whatever. And that kind of standing on the shoulders of giants is what I'm trying to get to here today. But specifically, I'll talk about this idea of DNS-SD for ISO 4 and that suite of standards, specifications, not standards. So what we're moving towards in this IP world seem to be incredibly complex systems. There's a lot of different layers in there, which are the things that bring the shoulders that we can stand on, right? Those different layers of the stack. But what I'm seeing, I still see the same thing that I saw 4 years ago, 5 years ago, which is that people are designing their networks, designing their 2110 systems by spreadsheets. I mean, they still generate a spreadsheet with all the hosts and all the speeds of the ports and all of the port numbers and all the switch numbers and all the uplinks on the switches and all the multicast IP addresses and all the host IP addresses and all the UDP ports they're using. And there's what VLAN or what switch, what IP addresses attached to each port for each host. It's endless designed by spreadsheet. And there's kind of nothing wrong with that organization. It's great to have all that organization. But what we really want to do is to do one or two things: either to automate our way out of that by using that spreadsheet as a source of truth, or try not to worry about too much of that stuff, try to use those higher layers in the kind of the stack that we're leveraging to deal with some of that stuff for us. I mean, we are obsessed with IP addresses and multicast groups. And do you know what? I mean, I'll make this point later on. You don't know what the IP address is of your computer or your phone or your wireless headset, right? And it's because you don't need to. And what I'm trying to cover some of in this presentation is how do we start to move more quickly towards a world where we worry less about the lower levels of this stuff and worry more about the application levels of this stuff, so that things become much easier and kind of more plug and play, right? This is going to be a bit of a rambling presentation because there's a lot of threads in here, and DNS-SD in NMOS environments is an important one, but it's just an example, okay? So you can have to bear with me. No, wrong slide. There we go. No, was a bit slow. There we go. Sorry. Hopefully you are seeing that one. So how do we start to lose that spreadsheet? Here's my example of how we start to lose that spreadsheet, right? We know everything by its IP address and by its multicast group, but most people don't know things by their IP addresses or their multicast groups. Most people know things by the host name or the web address or some meaningful friendly name. So, you know, amwa.tv, we know how to get to amwa.tv. We don't know what its IP address is. I could go and resolve AMWA's IP address using a DNS server on the web, 8888 will get you to Google's DNS servers. And you know, that's how your web pages are finding the content that you're trying to get to. It's not because you know the IP address, it's because you know the friendly name. And the same is true in local area networks in WANs, where each of the hosts will have a friendly name. It's got a machine name. So, you know, rdsa.gplab.local. I mean, gplab.local is my local domain. It's local to my house. It doesn't go anywhere else. But I can resolve using a local DNS server where rdsa.gplab.local is. And, you know, on my network, it's 192.168.100.20. I mean, I can remember that, right? But I don't need to, because I know the service or the machine I'm trying to get to is RDSA, and it's in my local domain. So we can start to kind of move away from having to know these numbers or worrying about these numbers if we start to use these high-level services. And when we kind of move to the ISO4 world, where we're looking to have a registration discovery server, which can provide the connectivity between all of our NMOS ISO4 enabled endpoints and provide the services that ISO4 does, we want to be able, our endpoints need to know where that is. They need to know where that RDS server is, and the backup, and the red one, and the blue one, and the amber one, and whatever colors you got, right? Now, in that particular case, what we're looking for is a service. We're not looking for a particular host, we're looking for a service. And the service, just one example of the services that are offered by ISO4, one of the services is the registration service. It's called _nmos-register._tcp. Whatever your local domain is, very catchy, right? But the point is that can be universally attached to an endpoint. So you don't need to universally attach an IP address. You can universally, in the code, you could say, I'm looking for NMOS register, right? It's going to be a .tcp because that's what it's defined as. What you need to know is what is the local domain to all your machines. And that'll be a single thing that you can put in once. So if I'm looking for a service, I can use similar services to DNS. It's called DNS-SD, DNS Service Discovery. And it's the same technique that is used to find your printer. For your computer, your laptop, to find your printer. Tons and tons of other services will use DNS-SD to enable devices to find something, a host that will render a service for them. In this case, we're looking for the NMOS register service. Now, early versions of ISO4 identified MDNS, multicast DNS, as the way to do that. And actually, for the first kind of interops and things like that, it was brilliant. It's very simple, it's serverless, it's peer-to-peer. But the multicast of MDNS, that multicast group is defined as a link, well, as a locally scoped multicast. It can't get outside of the subnet. It's not routable. It's not allowed to be routed. And so MDNS, to do all of this work, is limited to a layer 2 domain. So it's completely non-scalable. Now, there are proprietary ways of scaling MDNS, but they're all proprietary. We offer one, Cisco offers one, everyone offers one, right? But they're all proprietary, and so it's not really the right way to go. Now, the right way to go is to use something called Unicast DNS-SD. And what that does is it moves to a server client-based model, where the hosts will use Unicast, which is, as long as you build your network properly, it's routable and it's scalable. It'll work across a WAN or a LAN, work across a VPN. So it's completely, you're now using completely standard techniques to provide scalability, reachability. All that you need to know now is, where is the DNS server? Now, okay, I've swapped needing to know where the DNS server is for needing to know where the RDS server, the registration discovery server, was. But do you know what? This kind of standing on giant shoulders thing, DHCP would do that for us, right? DHCP on your laptop gets you a DNS server, gets you an IP address. You don't know how any of it works. It just magically works, right? When you're on a Wi-Fi hotspot or the network or wherever, those things work. So what you'll find is if you look at the JTNM's TR1001, it lays out a lot of these building blocks, standards that already exist that we should be trying to build into our endpoints and leverage. And then it references, or it references the pyramid, right? So the EP pyramid. So this stuff is laid out for us. What I want to do is to dive in a little bit more to some of the things to think about when we're building these DNS-SD systems. So the JTNM TR1001 kind of provides us with an example, and I'm stealing their picture because it's a nice one. It's a nice starting point. So you can see in here we've got an amber network, a blue network, we've got media nodes, we've got PTP. They show DHCP. That's kind of out of scope of this conversation, but I've mentioned it already. And they show all of those other services, DNS, the broadcast controller, the RDS, ISO4 in the control network. Now, that's really nice. It's a really clearly defined separation between the media network and the control network. Most people want to try and avoid connecting them together because it scares people, but it's a simplified view of the world. It provides exactly the information you need to know that there are all these services you can offer somewhere in the network, and it provides an opportunity to, provides an example of where to put them. But what I'd like to do is kind of dig through those a bit more deeply and explain why there are different options to where you put these services, things you need to think about in terms of how you're going to build a network that works for your particular case, or how you can build a DNS-SD service that's going to work for your particular use case. What you spot in this drawing is it shows the media nodes attached to both, well, all three networks, and it shows the RDS attached to the control network. Now, those, I don't know where those decisions came from. It's probably just a graphic to show what you could connect to what, but I want to dig more into that, right? Because what we discover is every single installation is different. I mean, I've seen that. You see that all the time, right? Every single broadcaster needs to do something slightly differently. So for example, maybe the RDS servers are actually connected to the media interfaces. That would make sense, right? That would provide resilience. That would provide direct access to those hosts through the amber and the blue network. Maybe the media nodes don't offer DNS-SD services on the media interfaces. So maybe they need to work through the management interface. Some customers do have really hard isolation rules where they don't want any of these things attached to anything else. They want routes that get you from the control network to the media network. So there's a lot of choices in play here, and we need to understand what we want to achieve, and understand what the requirements of our networks are with the customers, or our customers' networks are with the SIs or the broadcast vendors. But the great news is we have tons of choices, right? So I'm going to present 3 of those choices. None of them are right, none of them are wrong, and probably none of them fit anybody, but something in there will fit most people, and you should be able to adapt from what is here, okay? Let's say we put all the services in the out-of-band network, as I call it, in the management network, as the JTNM calls it. Control network, as I call it. This is really simple, really nice, really simple, right? So media endpoints talk media to the media networks, and they talk the control protocols to the out-of-band network. So there's no need to link the out-of-band networks and the media networks. They're completely isolated. So that ticks that isolation box. If you think about it, this means that the media endpoints only need to know about one DNS server. They only need to know one DNS address. Because there is only one, right? It's at that common out-of-band network. And in this case, there's only a single RDS address. There isn't a red one and a blue one. There's just a common one, right? So really simple. But what happens if the endpoints don't support Unicast DNS-SD on their out-of-band ports? I mean, that's a design choice for the vendors, right? If they don't, you can't use this. And does only having a single interface that connects you to all those services, is that enough resilience? Does that give you the resilience you're looking for? I mean, maybe they've provided a port channel, an LACP port channel, or maybe they haven't. Maybe it's a single RJ45, in which case I'd argue that wasn't enough, right? I mean, everything else is massively resilient. It's no point if you can't control the thing. So that's an option, nice and simple. Here's another option. All services are in the media network. This is also nice and simple. Everything is available through one of the media interface connections. So again, There is no connectivity between the out-of-band network and the media network, so perfect isolation. But again, if you dig into it a little bit, you'll discover that this also requires a bit more complexity. You know, it's not as simple as that, right? If, for example, like the media endpoints have now got these two interfaces from which they can send a DNS-SD request. So, you know, how do they work? Do they send one out of both? Do they send one out of one? Do they alternate? I mean, I don't know how it works. I mean, I'm willing to bet that they don't all do the same thing. So there's probably some complexity there. If the RDS service and the DNS services are not in the same subnet as the media endpoint, which is very likely, right? I mean, a big network, they won't be in the same subnet. You'll have sliced that up to make it reliable and resilient. Then do the endpoints have routing tables? They know how to get to the, you know, does the media endpoint know which other subnets are reachable through the Amber network, or does it have to guess? Because there's nothing that naturally tells you that. I mean, it understands its gateway, but it doesn't understand the rest of the network beyond that unless it's got routing tables. So it would have to make an assumption about how to get to the Amber DNS server. And does the Amber DNS server only provide Amber network information, or is it going to provide both? Does the media endpoint ask for Amber out of Amber and Blue out of Blue, or does it ask for everything out of just the one? So you can see there's a whole load of complexity here about how the endpoint manages the information, which could come down either of these links, depending on which ones it asks it from, and how the DNS servers are set up. So what we've built here is simple in network isolation terms, but really quite complex in other terms. So I kind of want to present my favorite, really, because it tries to find the best bits of both of those. So this one, I couldn't think of a better way of calling it than a mixed service model. So this one is more complex than the previous two, but the complexity brings flexibility, and it actually removes, you're adding complexity in the network, but it's removing complexity in the endpoints. And I'd say arguably that's the way to do it, right? Because networks are incredibly mature, routing protocols are mature. Pretty much every network's got a way of doing the things you need to do, providing routes and blocking traffic, limiting multicast. So it isn't true that every endpoint has got the flexibility needed to sit in the other two models I just described. So in this case, we purposefully connect the media networks and the out-of-band network. We provide a DNS service with a single IP address. So it doesn't matter where you ask for that DNS server from, you're going to get to it, right? Now you've got a route from the Amber to the out-of-band, you've got a route from the Blue to the out-of-band, and you may have to route from some part of the out-of-band to some other part of the out-of-band. But the bottom line is there's no confusion. It doesn't matter where you ask for that DNS server from, you can build a network which will deliver your traffic to the DNS server. It can support endpoints that only talk through the media interfaces because they're connected, and it can support media endpoints that only talk through the out-of-band. Now, in this particular case, I've drawn the RDS being an RDS that connects to both Amber and Blue, but honestly, it doesn't matter if you move the RDS up to the DNS, up to the same management, up to the network that the management is on, that works fine as well. And so there are some questions you need to ask yourself, and that is what address, you know, when you ask for the service, when you ask for the _NMOS dash register dot blah blah blah, what answer are you going to get from a DNS server? Because if the media endpoint asks from the through the Amber interface, maybe we need to provide it with an Amber address for the RDS. If it asks through the Blue interface, maybe we need to give it a Blue interface for the RDS. I don't know. These are all questions that we need to, you know, you'll see when we look at the conclusions. You need to understand how your endpoints operate, because how those endpoints operate will enable you to understand what network you need to build. And it may well be that what we need to do is go back and talk to our endpoint vendors and ask them for some specific capabilities, because having many different sorts of capabilities is making building a single design for this really quite complicated, which is why I've already got 3, right? And whatever you design will be a 4th. So there are some things to note though. Most DNS servers will support zone scopes, which means you can ask them to serve different IP addresses for the same host or the same services differently, depending on what IP address the request came from or which interface the address came in on, for example. So it's possible that a request up the Amber network through the outbound network will receive a different answer to the one that would come up the blue one. So a simple simplification would be if the media endpoint asks for an Amber, asks through the Amber network with an Amber source IP address, give it an Amber response. If it asks through the blue with a blue source IP address, give it a blue response. This all trickles back to you having to think carefully about your IP addressing in the first place, right? Make sure you've got consistent and coherent sets of addresses for Amber and blue so they can be easily subdivided, or can't remember the right word for it, but don't worry, you know what I mean, right? But you need to understand how a tri-connected endpoint will behave. Will it ask through all of them or one of them, or can you configure it? Or I don't know. I mean, there's many different designs out there. Really, you need to take an awful lot of care to make sure that the outbound network doesn't end up with traffic you don't want on it. You don't want multicast traffic in that network. You don't want to flood stuff into that network. You don't want bandwidths that are going to cause trouble in that network. So, good bit of network design in terms of routing and in terms of where you've got PIM enabled or where you've got multicast boundaries is kind of the thing to do there. So this is a very quick whistle-stop tour through this stuff. Having kind of, pushed the door open to say that there are ways we can move away from the spreadsheet design, I see DNS as one of those steps towards the benefits that I described in TR 1001. Honestly, having jumped from the broadcast world to the network world, I see that an awful lot of the problems that we believe we've got in 2110 over the years, they've already been solved. I mean, there are standard ways of doing this stuff in IT or in IP. So it's great to see that we are, organizations like JTNM and AMWA are busily trying to find reuse capabilities that exist in the wider world, because that's exactly what we should be doing. We should be, not differentiating at some of these levels, but differentiating at the application level, at the kind of creative levels, not at this technical, can we bolt it together levels. As we mentioned earlier on, I mean, DHCP would be an amazing accompanying technology here, right? You don't need, if you enable DHCP and you've got a DHCP server set up, then now you don't care what the DNS address is, because DHCP will serve that to you. You can change it whenever you want. DHCP kind of requires that you can, that high level tools can operate at the level of not worrying about IP addresses too much and talking about hosts, because that's where there's nothing is bolted in here potentially. Although you can tell DNS to serve addresses, DHCP to serve addresses that are pretty hard prescribed. That's definitely doable. So you can still get the ability to move a camera around and understand what its IP address is going to be with a decent DHCP configuration. Of course, DNS allows you to dynamically update those records. So, being able to update the DNS records means that endpoints can come online and tell DNS what its address is as you change it. That means that your systems are all self-consistent. And one of the things that would be lovely would be to kind of continue this thought of using DNS, and I'll extend that out to IPAMs, Internet Protocol Address Managers. There's nothing to stop us using those sorts of technologies to manage IP addresses. You don't need to pull them out of a spreadsheet. You can pull it out of an IPAM, and then having pulled it out of an IPAM, you can push them into the DNS using dynamic, updating of the DNS server dynamically. So this stuff can all be. It doesn't have to be prescribed. It can do its own thing, and you can still know what the answer is, and you can still, take the benefits of IP, but at a higher level. So there are ways to get much more kind of plug and play. I just got a couple of slides to conclude. So these are relatively simple drawings. And what you've got to do is you've got to spend some time thinking about resilience as well. So when you're talking about resilience, we're talking about kind of multiple bearers. So, you know, no single links between two places. If you lose one of those, you've lost something, right? What you want is resilience by multiple bearers. Often, you know, as many endpoints as you can to have multiple physical connections into things. Think about how how is your RDS provider going to provide you with resilience? Do they have a main and backup? Do they have an active? Do you need one address for the RDSs? Do you need two addresses? You have to have a chat with them about how they're going to achieve that, right? Because you want an RDS to be able to go down, and then you need the DNS system to be able to potentially respond to that, or you need everything to always have the same address. You know, one of those mechanisms has to work. So you have to think about the failure scenarios. How's the DNS going to be resilient? Can you support multiple DNSs? Can you support multiple, can your endpoint support multiple DNS IP addresses? I mean, your laptop can, but can the endpoint support multiple? Or do you need to use some other method to make sure there's always a DNS server at the address that you told everyone the DNS server is at? And then, given that there are, we've already seen 4 design patterns, right? So there's going to be more. You've got to try and design this stuff in from the outset. I would recommend you get your IT guys involved, because DNS is part of every single enterprise. It's already there. So hopefully there's somebody who understands how the DNS system works and can help you to, navigate through DNS-SD. Consult with your endpoint vendors as to the capabilities, because they're all different. And what you don't want to discover is you design a system which suddenly leaves you unavailable or unable to use a critical piece of infrastructure later on. And consult with your RDS vendor, because the same is true there, right? You need to know that whatever mechanism you're using is going to be compatible with whatever you're thinking of doing. I want to point out that a lot of, if you're looking for a technical presentation, this wasn't it. But there's a brand new NMOS implementation guide for DNS-SD on the AMWA website, which does have a lot of the technical information that if you were wanting technical, that's where it will be.